Right. Good morning, friends. Good morning, nerds. Ah, what a great group of nerds. Where are all the nerds at? Come on. Can I get a hello? Can I get a wave? As in, you guys all do the wave. That'd be fun, I thought. Guess that's a hard no. All right. Okay, cool. That's fine. Great. Glad I woke up this morning, started my live stream just so no one could say hi to me or good morning, except for Charlie. Appreciate that, Charlie. Big shout out. And still, okay. Well, you guys are no fun. All right, so let's go ahead and go through our warm-up here. Good morning, RJ. At least I can count on him too. Depending on, you never know when he'll show up, but you can at least depend on a good morning. I just got here. A little late, man. Do you have a pass? Fine, good morning. Thank you. I appreciate that. It means a lot. RJ, did you just get here for music or what? He's tomorrow. Oh, okay. Also, good morning. Good to see you, buddy. All right. See, this is better. This is a much better way to start. I got 4 good mornings. I love it. I appreciate it. All right. Need that human interaction. I told you. I sit in this room and I talk to myself for 4 hours a day. And that's just the math part. Let's not even think about all the other hours that I'm talking to myself. All right, so let's determine the convergence. So when we look at this, now yesterday we talked about the ratio test, so a pretty good chance that that's what this is going to be. But the way that I would recognize that is by seeing not only do I have an exponential, but I also have factorial. So the ratio test is very good for when we have things that involve exponentials and factorials. All right, so we hit both of them here. Let me guess, he's at a meeting. Who's at a meeting? Are you talking about me? I don't get it. Who's at a meeting? So the ratio test tells us, let's see what happens whenever we take the limit of the ratio of n plus 1. So what happens if I substitute in n plus 1? So this blue part will be my a n plus 1. So n plus 1 minus 2 so n minus 1 factorial, over 4 to the n plus 3, but we're plugging in n plus 1, so n plus 1 plus 3, so n plus 4, divided by an, so that's just my original, the original sequence, n minus 2 factorial, divided by 4 to the n plus 3 factorial. If Max was in here, I would have said Joe. Max was in my college algebra class last block. He taught us how to do a problem. It was good. Okay, so this is just the setup. It's cutting up. Is it messing up for anybody else or just Rocky? RJ, you wanna come in and do one of the problems later on? Just Rocky. Totally will. Okay. All right, I'll cue that up for the next one. That's really funny that you just said that based on... Anyway, so I'll show you. But... so n minus 1 factorial over 4 to the n plus 4 times, so let's multiply by the reciprocal, 4 to the n plus 3 over n minus 2 factorial. Okay, so again, if you can just do the simplification here and see it, then great. If you need to do it off to the side, do that as well. It doesn't matter. So just to show explicitly what we're doing, you don't have to always do this off to the side, but let me first think about 4 to the n plus 3 over 4 to the n plus 4. I think you're good. All right, cool. Welcome back. All you missed was everybody saying good morning to each other because we're all such kind, good friends. Now that denominator, 4 to the n plus 4, if I take out a 4 from it, so that would drop my exponent down by 1, so 4 to the n plus 3, which means I have 4 to the n plus 3 over 4 to the n plus 3. So that cancels, which means this is just equal to 1 over 4. Okay, so I know that simplifies to 1 over 4. Now, let me also think about doing this simplification. Let me be clear, when I do these, when I'm circling these in the yellow, I'm not cross multiplying. I'm not cross multiplying. I'm just showing these are the groups of things that we're simplifying. So n minus 1 factorial over n minus 2 factorial, right? Yes. Equals, so n minus 2 factorial, that denominator, I know that is the same thing as n minus 2 times n minus 1 factorial. which means these will cancel. Leaving me with 1 over what? Plus 2? Oh. Wait. Plus 2 what? I'm confused. What am I missing? Shouldn't it be n plus 2 times n minus 1 factorial? No. No, because we're just talking about n minus 2 factorial, so means we take whatever n minus 2 is, and then we multiply it by the number 1 less than that. So if we subtract 1, that would be n minus 3. And then we multiply that by whatever's 1 less than that, so that would be n minus 4 and n minus 5, etc. But okay, actually that would be different. Right? Okay, I did screw up, not in the way that you thought. But so this is n minus 3 factorial. Right? Because n minus 3 factorial is just n minus 3 times 1 less than n minus 3 times 1 less than that times 1 less than that times 1 less than that. So actually, thank you for bringing that to my attention accidentally. Okay, let me start this fresh. Okay, so what do I have? So n minus 1 factorial over n minus 2 factorial. Okay, so actually, n minus 1 factorial is the same thing as n minus 1 times n minus 2 factorial. So I was thinking about it as plus signs. Yes, exactly. You nailed it. All right, I was thinking about plus signs. All right, so yeah, do be careful about how the factorial works and which one. So the n minus 2 factorials would cancel. Just leaving me with n minus 1. All right, so back to my limit. So n minus 1 over 4, which as n goes to infinity, so the denominator is stagnant at 4, but the numerator is just increasing to infinity. So this diverges. Okay, so for the ratio test, it doesn't even have to be that it diverges. It's just if this limit that we get is anything greater than 1. Okay, so even if we had gotten 1.1 as our answer for the limit, that still means it diverges. So since we got infinity for our limit, well, then it definitely diverges. So we can say our series from 1 to infinity of n minus 1 factorial over 4 to the n plus 3. Is that right? N minus 2 factorial, sorry. Diverges. How do we know? By the ratio test. Ratio test is all just about simplification. All right, use the exponentials, the factorials to manipulate that limit so that a bunch of stuff cancels and you can actually figure out what the limit is. If it's less than 1, converges, greater than 1, diverges. And if it equals 1 exactly, then it's inconclusive. We're not sure. For the ratio test, what things have to be met to use it? Nothing. We can do it whenever. If it works, it works. But it just has to be that we're able to find that limit. So sometimes if the limit's not something, not everything will nicely cancel like this, but factorials will and exponentials typically will. So yeah, we can use the ratio tests whenever we want, if we can make that limit work and figure out what it is. All right. So let's talk about a couple of summaries here. Let me bring up. So I sent you guys a few different documents. All right, and the first thing I'm going to show you is actually not even from the document at all. One of those documents. Okay, and that is this. So this is page 636 from your book, right? And as stated, it's a summary of tests, so that's nice. Let me zoom in here. All right, again, page 636. So you all have this in your textbooks. You all magically found that. Also digitally, you might have your textbook because we, by random chance, found a flash drive in class that one day that had the PDF of the book on it. That was crazy. I can't believe you guys found that. That was weird. And it has everything we've talked about. Now, the problem with these sheets is they also have more stuff, because normally we would have learned all of this stuff, but we can't learn all of it. Or, well, we can, but we're not going to focus on all of it. Flash drive manipulation. That was shocking when Charlie picked up that flash drive and just entered it into his computer, just without any coaxing or whatever. It was just the fact that there was a flash drive, and immediately plugged it in and see what was on it. All right, so let me go through and make sure we know exactly which ones we have that we've talked about. Okay, that first one is the nth term test. Okay, nth term test. This is the one we want to do first. If we happen to know one of the other ones, can we use it if it applies? That's a good question. Yeah, I would assume so. They're not going to count you off for using something, but you shouldn't need to. Anything that you need to do on the AP test should just be one of those. But yeah, if I can't imagine you would be counted off for it. Right. Nth term test is always a good place to start, because the nth term test is just take the limit. If we find out that the limit's not 0, then great, we automatically know it diverges. And what's nice about this is, kind of like RJ just asked for the ratio test, we don't need to prove anything else beforehand. We don't need to show that something's decreasing or that something's positive or anything like that. We just take the limit. If it's not 0, boom, we know it diverges. All right, so that's always a good place to start. Geometric series, all right. For here, we just have to look at the ratio. If it's less than 1, it converges. Greater than or equal to 1, diverges. And we can actually figure out what the sum is by using this formula. Right, we can actually figure out, if we add up these infinite amount of numbers, what's the number that we'll get? What's the answer? It's this. Okay. Telescoping series we did talk about, but I taught this before I knew what the list was. So this is not actually on the list for what will be covered on the AP exam. So we did learn this, and it is good to know, but it's not on the list. So don't focus too much attention on that. Still good to know, though. P series, very important. Almost 1,000% positive you'll have to do a P series. You'll have to know a P series. All right, super, super common. So a P series is of this form, 1 over n to the p power. It converges if that exponent's larger than 1. It diverges if it's in between 0 and 1, or equal to 1. Alternating series test. Okay, so if we see that -1 to the n minus 1 power, we have to show, this just says that it's decreasing, and the limit is 0 as n goes to infinity. Right? This is one of the series where we have to have certain conditions met. Integral test, we have to know, and also for the alternating series, sorry, this is also, it's not listed in there, but this is also one of the conditions, is that the sequence has to be always positive. Okay, sequence positive, sequence is decreasing, the limit equals 0. Integral test, we need to check 3 things. Is it continuous? Is it positive? Is it decreasing? Right, continuous, positive, decreasing. Then we can take the integral of whatever that sequence is. If it goes from 1 to, if it converges, then that means the series also converges. If the integral diverges, then that means the series also diverges. There's also a remainder, but we don't talk about that. We skip the root test. Ratio test is what we just did. If we take that limit and it's less than 1, it converges. If it's greater than 1, it diverges. If it equals 1, then we're not sure. Direct comparison. So this is when we compare it to something that we know converges or something that we know diverges. And depending on which way we can prove that this is less than or greater than, one sequence is less than another sequence or greater than another sequence, we could prove that our series converges, or we could prove that our series diverges. Now, this one we had to be careful with, because if we're proving that it diverges, right, then we have to prove that the lower sequence diverges to force the other one up. If we're saying that it converges, then the larger sequence has to converge so that it's forcing the smaller one down to converge as well. Limit comparison we did not do. It's related to the comparison test, but we don't need to do it. And that's kind of our summary. All right, 636. Now let me double check again. I'm going to list out exactly which sections are or aren't on this. Just give me a moment. Scroll through some pages. Come on. Okay. So, let's see. 10.2, which is geometric. All right, I know you can't see it right now, but I'm writing this down on the Smart Notebook, and then I'll show you the specific list. So, geometric. 10.5, harmonic and P series. 10.7, alternating series. 10.8, ratio test. 10.11, that's something we haven't gotten to yet. Okay. But it's not a test. So these are the 4 specific tests that AP has said you need to know. Right? Geometric, harmonic and P series, alternating series test, ratio test. Okay, so write that down somewhere. These are the 4. Now, we learned other things because we didn't know yet what AP said they would or would not have. So here's a list of things that we learned that are not specifically on it. Okay. Which is telescoping, comparison test, and what, isn't there one more? Integral tests. I think that was it. Yeah. Okay, so these 3 are, yes, we learned them, but at least as AP tells us now, this is not going to be on the AP test. So here's what I'm thinking. I'm thinking that to organize this for us, like on Summit, that I will make this the series PFA. And I'll make these the AFA. All right, just for organization wise, so that you can look and think, oh, okay, the PFA, these are the ones that are directly, or that are going to be on the AP test, or the ones at least the AP College Board tells us we need to know for the AP test. And the tests from the AFA are, we learned them, but not going to be on the AP test. Is that a good way to go about it, do you think? I think that's good. Okay. Yeah, well, you've answered this before, but AFAs are definitely required, right? Yes, as of now, I haven't heard anything differently about that for AP, so I will operate under the assumption that AFAs are still required. Now, depending on how things turn out, maybe that's flexible in the future, but I would, to be safe, I would just assume that yes, they are required. So I also sent you another document. Let me bring it up. Harold Series Convergence Test Cheat Sheet, March 24th, 2016. Thank you, Harold. Today's stream sponsored by Harold for his wonderful cheat sheet. I started making one of these myself, and then I was like, you know what? I bet plenty of other people have made some, and I bet they're way better than I could make anyways. So this is basically the same thing. It's just written a little bit differently. Maybe you like this one better. Thank you, Harlod. Harlod is my best friend. Okay, same one. So nth term test. Again, this is a great place to start. This is such a quick test that you can often just look and imagine, oh, would this limit be 0 or not 0? Well, if it's not 0, we can automatically say it diverges. So nth term test, wonderful first quick test. Geometric series, same stuff. P series. Alternating series. No, Siri, I don't want to talk to you. Go away. Integral test. Ratio test. Direct comparison. Root test we didn't do. Limit comparison we didn't do. Telescoping series we did. Also, there's a nice little flowchart here, which I think this is also helpful from Harlod. So it kind of gives you a good breakdown of Now you could do it differently, but if you're totally uncertain of what the heck you need to do, this is a good flow chart to follow. So again, the first step is just do the terms approach zero. Well, no, then great. We know it diverges. Harold calls this divergence test. That's the same thing as the nth term test. Okay, that's exactly, he puts both names up here. Divergence or nth term test, whatever. All right, so start there. From there, it's just about what can we identify? Can we identify alternating signs like that -1? All right. Would it be easier for us to integrate? Maybe we could use the integral test. Do they involve fractions or powers of n? Comparison test is usually good for that. Okay. Factorials or exponentials? Ratio test is great to use. Okay, so it kind of gives us a good flow chart. Now you don't have to look at that, but if you're totally lost and have no idea where to start, it's a good kind of protocol to go through. Now this is not even Harlod's, you see. This is Davlid J. Manuel. Right, so thank you, David Manuel. A lot of collaboration going on here. And thirdly, I also sent you this. Strategy for testing series. This is basically just kind of that flow chart, but in just words form. Right? It gives you various checks you can run through. Right? It gives you a strategy. This is just more about what you need to identify. Right? So, 1 over n to the p series. Something of this form, geometric series, etc. Right? Divergence test, alternating series. Number 6, series that involve factorials or products, powers, ratio test, etc. Okay. Gives you a couple examples, well, a lot of examples actually, of how to just figure that out. And there's a ton of good practice problems here. Now, not all of these are applicable because some of these have tests that we didn't learn. But also, if you scroll down more, so here's all the answers. Wait, what is those for? Not those answers. This is not multiple choice. Oh, click here for, yeah. Okay, so in the actual solutions, for the odd ones at least, it breaks down the full solution of which test did they use, the steps. It's written out kind of short. It's not super specific, but it still writes out the general steps and simplification, and then how you know by which test. So this would be a good thing to study through as well. Again, it gives you all the odd solutions, and you could take a look. The even ones you don't have, but the even ones you could type into Symbolab or type into Wolfram Alpha. Either one. Okay, so I try to give you a lot of different resources of things to use. There's that page in your book. There's Harlod. There's Davlid, the flow chart. There's this description of strategies, and then a bunch of examples that you can work through as well. Okay, so are we ready for RJ to teach us something or to go through a couple examples with us? Not sponsored by Blue today. Today we are sponsored by Transparency. Okay, so little does RJ know, I was actually fully planning on incorporating him into this lesson anyways, in the same way that I planned on incorporating Max into my last lesson. And so this is already set up. Before RJ offered to pop into this stream, I was already way ahead of him. So let's go ahead and bring... Oh, okay. Oh, RJ, you good? You ready? You want to be on the stream? Yeah? Okay, give me a second. I'll switch out. Okay, guys, we're ready. Let's do this. Just want to say a big shout out to Mr. Abundance for having me on the stream. What a great day. Man, I miss seeing you guys. I'm sure you miss seeing my smiling face every day too. Good morning. Good morning. This bit brings into question the existence of a merciful God. Well, maybe. All right, let's do this. Determine the convergence of the series. Justify your answer. Okay. So, we have different options. Okay. RJ, where did your neck go? Don't worry about my neck, okay? I'm trying to teach math. I don't have time for you trying to distract me, Hayden, okay? Good place to start, like Mr. Abundus told us earlier, is just with the nth term test. So let me first just think of what is the limit of this sequence. Well, denominator is growing. 1 over a very large denominator, so that's going to go to 0. Which just means it's inconclusive. But again, great place to start. Especially because this limit is really not something that you even need to write out. You could probably just look at this and immediately tell, oh, if I take the limit as n goes to infinity, yeah, that limit is going to go to 0. So it's inconclusive. So it's just a really quick thing that you can do, because if it works, then we can automatically say that it diverges. If it doesn't, then we're screwed. Okay, so in this case, we're screwed. We need to go on to some other type of test. All right, so we have different options. We have telescoping, we have alternating series, we have P series, we have comparison, we have, all that good stuff. Okay. And for this, so as I'm thinking here, what does it need to be? Well, does it look like an alternating series? No, because I don't see that like -1 to the power of anything. So I don't think it's an alternating series. It does not look like a geometric series. All right, it's not in that form of a times r to the n minus 1. And integral test, I could potentially do the integral test, I think. Let's see, what else do we have? Ratio test. Wouldn't be good for the ratio test because I don't have just powers, like where n is in the exponent, and I don't have factorials, right? I don't have exponentials or factorials. I just have a polynomial in the denominator. RJ, why aren't you social distancing? I am. Who said I'm not? I'm social distancing. Who's around me? Nobody. But when I look at this, what I do think is, hey, wait a minute. 1 over n squared, I know what 1 over n squared would be, because that's a p-series. Okay, so let me try to compare 1 over n squared and 1 over n squared plus n. N squared plus n, that would be a larger denominator, which means a smaller number. And since 1 over n squared is a p-series, or p is equal to 2, and for a p-series, anything larger than 1 for the exponent converges. Our original sequence is smaller than that, and so if that's converging, then it's going to be forcing our other one to converge as well. Well, I guess not just the sequence, but the series. So we're able to identify a part of the series that converges, right? And when we compare it to our original series, since our original series would be less than that, it must also converge. Yeah, don't mind me. I typed in the chat "mwahahaha" because I thought that would be a good thing to type. Okay, determine the convergence of the series. -3 to the n plus 1 power divided by 2 to the 3n. And that's from 1 to infinity. So when I look at this, if I'm first thinking nth term, so if I had to take the limit of this as n goes to infinity, I really don't know. All right, I would have to keep using L'Hopital's rule like forever, and I don't know that I would get into anything conclusive. So nth term test in this case doesn't tell us anything, but it's a good first check, and it goes quick. So now when I look at this, what I'm thinking of two things. I'm thinking alternating series test, and I'm thinking ratio test. These are the two options that stick out to me the most. Now, why is that? Well, the alternating series test, because if I see -1 to the n plus 1 power, okay, then that makes me think of alternating series. However, ratio test, I'm thinking because there's exponentials. Betting ratio test, ratio. I think you're probably right. I think that ratio test would be the best way to go about this. Because for the alternating series test, since we have to prove certain things, right? For alternating series tests, we have to prove that we're a positive sequence, a decreasing sequence, and that the limit of the sequence equals 0, which I think those things would be hard to do with this one because of the exponentials. So I don't know about that one. So I'm betting the good way to go for this would be ratio test. Because like RJ asked at the beginning, we don't need anything. We don't need to prove anything extra in order to do the ratio test. We can just do the ratio test automatically, immediately. All right, we don't need any other conditions to be satisfied. It's just an extra hair. Okay, so I would say recommend doing the ratio test in this case, but I'm actually going to go through and do it. Okay, here, n squared minus 1 over n squared plus n. I'm going to first start off with the nth term test. All right, this is an. So that numerator would go to infinity over infinity. So let me do L'Hopital's rule. Two n over 2n plus 1. That also goes to infinity over infinity. So I'll do L'Hopital's rule again. Two over 2, which is 1. So great. Without needing to do any huge amount of work, I can just automatically say that I know this diverges. And again, nth term test is great because we don't need to prove anything else before. We can just do it. Okay, -1 to the n times natural log of n over root n. Okay. Nth term test would be difficult in this case. Well, good morning. Hi, Miss Jury. Doing the nth term test would be weird or difficult. We'd have to do L'Hopital's rule, which would mean we would need, well, I guess it could work, but I think we would end up at 0. So, well, alternating series as well. So it would be tricky. About time RJ taught the class. I agree. I've been preparing all school year so that I can finally take over for Mr. Abundis. He sucks, so time for me to step up and teach, even though I do have to leave to go to music soon. But since I'm seeing in this case that I have that -1 to the nth power, okay, what that immediately makes me think of is maybe an alternating series. Which probably would be my best bet. Okay, so again, now alternating series test, we do have to prove some things. Right? We have to prove that, oh shoot, wait, I always confuse it with the integral test. We have to prove that the sequence is positive. We have to prove that it's decreasing, and we have to prove the limit of this piece equals 0. Okay, which would be easier to do using L'Hopital's rule. Uh, 1 over n times natural log of, or sorry, times square root of natural log of n. All right, there's a lot of ofs we got to get through. We just have to make sure, first of all, that we're saying it correctly, because who knows? We could be doomed. And that is the series from 2 to infinity. I'm not thinking alternating series. I don't suppose there's a fraction test we're about to learn. No, but we have, in this case, we do want to use the decimal test. Right? That's the most important test that we're going to learn here. So all you do is you take everything and you turn it into a decimal. Infinity 0.0 n equals 2.0 1.0 n divided by 1.0 times the square root of 1.0 times natural log of n plus 1.0 minus 1.0. Okay, so now that we have decimals here, we can finally understand what we're looking at. Right? This is much easier to do. So I just popped in. It's safe to assume he's been RJ all class. What? No, Mr. Abundis came in at the beginning, taught some garbage, and then he brought me in as well. Tag team. Just the important part. Mainly here for the decimal test. Write that down. Okay, so actually, if I just think to myself, the nth term test, so if I took the limit of this sequence, it would equal 0. So that's inconclusive. If I do, this doesn't look like an alternating series. Okay, it doesn't look like a geometric series. It doesn't look like a P series. Comparison test is a possibility, but I would be hasty about comparing like 1 over n to square root of natural log of n. I wouldn't be comfortable saying this one side is definitely larger or smaller than the other, depending on what the value of n is. Okay, so that one might be tricky. Okay. So I think what I would fall to for this one would probably be doing the integral test. This sequence would be positive. It's continuous since we're going from 2 to 0. I think we could prove that it's decreasing. Yeah, so I think the integral test here would be a best bet. And now that's mostly because I feel comfortable that I could do this integral. So remember, part of the integral test is just when we look at this, do we feel like we could integrate it? I feel good about that because if I make this, when I integrate this, I would need a u substitution. So natural log of n. So du equals 1 over n. So that would take care of that 1 over n on the outside of the square root. So I think this would be a good thing to integrate using just a u substitution. So yeah, I would feel comfortable saying we would need the integral test here. Okay, and I think this is our last one. All right, but hopefully we're recognizing this one. I have exponentials. I have factorials. Probably our best case scenario is to do the ratio test. And that was our last one, right? Yeah. So if you want to actually see these done, these are all on that one PDF I sent you that has all the practice problems and the solutions at the end. These are all examples from there. But getting comfortable doing these is just recognizing what is important for a test to work. For ratio test, it helps that we have exponentials, factorials. P series, 1 over n to the power of something. Geometric series, it's in our geometric form. Alternating series, we have some sort of -1 to the power of something. Okay, and etc. and so forth. Okay, so it's about recognizing key pieces that we can then say, I think this would be the best test. But sometimes we might have to try more than one. Maybe we try a test and it doesn't work, so maybe we go on to the next one. All right, we do that a lot with starting with the nth term test. Well, maybe it would be too difficult, or maybe we don't get, or maybe we get 0, so it's inconclusive, but it's a good place to start. Okay. Do we want, oh, you want to come in? You want to talk to them? Yeah. Okay, yeah, you can come in.